Okay, so now we will solve this question, which is about application of Clausius-Claperon equation. The statement is given, which is at a temperature of 60 degrees Celsius. So we can write this data here. So here we can say this is data. So the data is T1, which is 60.6 degrees Celsius, and we need to convert this into Kelvin. So basically this becomes 0.6 plus 273, that is 333.6 Kelvin, and benzene exerts a saturation pressure. So this is first saturation pressure, P1 sat, which is 400 torr. So we don't need to change this unit for the time being, because in this case units will be cancelled. Then at 80.1 degrees Celsius, which is T2, 80.1 degrees Celsius, which is plus 273, that becomes 353.1 Kelvin, and its saturation pressure is 760 torr. So this is P2 sat. (760 torr). Using only these data, so basically at a temperature of 60.6 degrees Celsius, benzene exerts a saturation pressure of 400 torr. At 80.1 degrees Celsius, its saturation pressure is 760 torr. So basically we have two temperatures and two saturation pressures. Using this data, estimate the enthalpy of vaporization, which is delta H of vaporization. This is part 1, and compare it to the reported value of delta heat of vaporization, which is 35 kilojoule per mole. So whatever the answer we will get, we need to compare that with reported delta H of vaporization, which is 35 kilojoule per mole. So basically it looked like the answer of delta H of vaporization will be around 35, and it should be in units kilojoule per mole, because that's how we can compare. Now basically now we have this two pressures and two temperatures, and for this situation we have Clausius-Claperon equation like this, which is ln P2 sat over P1 sat is equal to minus delta H of vaporization over R 1 over T2 minus 1 over T1. So this is basically Clausius-Claperon equation. Now we can put the values in this. So ln P2 set is 760 torr, P1 set is 400 torr is equal to minus heat of vaporization. That's what we need to calculate. And R value is, I think, let me double check. I think it should be 0.08314 or 8.314. So let's do this. I think R can be used as R value 8.314 joule over mole Kelvin. Remember, the answer in this case will be joule per mole, and then we will convert this into kilojoule. And if you want to directly convert this equation answer to kilojoule, then you can use R is equal to 0.08314 kilojoule over mole Kelvin, right? So now we can put this value directly if you want. This is 0.08314 kilojoule over mole Kelvin, and T2 is 353.1 Kelvin minus 1 over 333.6 Kelvin. So basically these are the values. Now if you can see this, Kelvin here, not this one. So Kelvin, oops. So basically Kelvin here is cancelled with these two Kelvins, and torr is cancelled with torr. So as a result, we will get answer in kilojoules. So basically delta H of vaporization, because if you see this equation, we have only one unknown, and if we will solve this using your calculator, so you will get the answer approximately equal to 32.3 kilojoule over mole, because that's the only unit remaining here in this case. So this is your calculated value. So basically this is calculated value. And now the second part is you need to compare it with reported value, which is 35. So you got your answer is calculated value is 32.3 and the reported value is 35. You can compare. Now comparison. So compare. So compare. So we are comparing here, or comparison. Reported value is, so reported value of heat of vaporization is 35 kilojoule over mole, and calculated value is 32.3 kilojoule over mole. Now how we can compare? We can compare using term called relative error. So basically we can compare this using relative error percent, which is equal to, the formula for that is, which is not given on your slides. You can do that like reported value minus calculated value, and I think it's divided by reported value as well. Let me double check. That's right. So basically it's divided by reported value as well. So in this way we can get reported value is 35 minus calculated value is 32.3 divided by reported value is 35 multiplied by 100. For percentage, this is multiplied by 100 as well. So in this case the relative error will be approximately, I think, 7.7 if I'm not wrong. Let me double check. Yes, 7.7 percent. So 7.7% less mean the calculated value of heat of vaporization is 7.7% less than reported value. So this is the overall solution for this question. So I hope this question is clear to you guys. So this is, I think it's a simple equation.